Welcome to Wiring Methods Lab number 6. In this lab we're going to talk about wiring of four-way switches. Four-way switches don't mean that we have four switches in the system. The four-way switch has four screws on it for four separate travelers. And so we're going to line it up with a pair of three-way switches. It's always used with two three-way switches. And you can actually add as many four-way switches into a system as you would like, and it will still work. And we'll show you a little bit of that here in just a moment. So once again, we're going to show you we're going to start with our simple circuit with a power source. Obviously in a home, it's not going to be a battery. It's going to be it's going to be your panel, but the fundamental is the same. With electricity, we have to complete a circuit, and so we can have just a simple switch that goes to a light bulb and then comes back with a neutral, and when we complete that circuit, if this switch gets turned on, then we have completed the circuit, which will turn on our light bulb. As long as we have a complete path all the way back to our source, our light bulb will come on. So whenever we're doing any switching, we always do the switching in the hot side. We're not breaking the neutral, and the neutral is always staying intact from the source all the way to the load. We're going to be going through multiple boxes, and so that may mean that it's separate pieces of wire. So that neutral's already been broken, and we're going to have to tie it back together with wire nuts. But we're not putting any switches into the neutral. Our white wire should not tie into any of our switches. We should only be tying in the black and the red into our switches. So we're looking at we have our source here. We have our black wire coming in. It's going to come to our first three-way switch, right? We're going to have a three-way switch here. We'll have our light bulb over here, and we're going to go ahead and have our neutral all the way over back. It's going back to the source, right? And so all we're doing is we're breaking our hot side. So we have our first three-way switch. We're going to have a wire going to our four-way switch, and then a wire going to our three-way switch, which is going to feed to our light. And so this is a switch here, go back with our red. So that's a simple drawing of our four-way switch. Now let's kind of explain what's going on here. So we have our hot wire coming in. We have a three-way switch. That three-way switch has three screws. 1, 2, 3. This first screw here is known as the common screw. These other two are travelers. Our four-way switch, it doesn't have a common screw. It only has travelers. It has four travelers. When we wire this up, we want to make sure that with our switch, our travelers that are coming from one three-way switch are both on the bottom or the top, and the other two are on the bottom or the top. We're not putting those on the sides. We're not putting them diagonal, and I'll show you what I mean by that a little bit more closely here in a moment. The way that a three-way switch works is, well, let me find the eraser here so I can erase the switch part here. So right now our three-way switch has been flipped in this direction here. our other three-way switch has been flipped in this direction here. So our four-way switch is a third switch that's somewhere in the middle of those two. It can be in one of two positions. It can be in the cross position, right? When you flip the switch one way, the internals of that switch would look like this, and when you flip it the other way, the internals of the switch look like this. So with the switch flipped in the direction it's flipped now, we have a clear path for electricity to flow into our light bulb and back to the source. Now if I flip that switch so that we have the cross situation, now that power is going to flow into that switch through this path, and it doesn't have a path to complete. So now if I flip this switch, we can complete the circuit. Or if I flip that back to where it was, if I flip this switch over here, then it creates a new path for the electricity to flow. So any of the three switches in the circuit that I flip, it will allow us for power to continue to flow through that circuit. And with four-way switches, as long as I have a three-way switch on either end, I can have as many four-way switches in that circuit as I want, and it still work, right? Like if we have a path here, we have us a three-way switch, and I draw in multiple four-way switches. Then we are still providing a path for, oops, that's not the spot. I got so many things, I got so many switches here, I can't even see them all. Yeah, that does go there. That goes there, that goes there. Alright, so I could have three-way switches at all of these locations. Need one more wire there. There we go. And so I have a path, right, for electricity. Come through here, then down to here, then up to here, then down to here. Oh, it stops right there. And so now if I flip any switch, right, so if I flipped this switch, I have a path for electricity flow. If I flip this switch, I create a path for electricity to flow. And so we can have as many four-way switches in between as we want, as long as we have a three-way switch on either end and the commons are attached to the right place, then we're going to be okay. So the wiring of a four-way switch, you're simply wiring in the four-way switch in between. You're breaking the travelers and wiring it into those travelers in between two properly wired three-way switches. So what does that look like on our actual drawing? So this is what that will look like in our actual lab packet. We'll have a cable coming in for our home run. We will have a cable in between our first two switches, a cable in between our second switch and our third switch, and a cable between our third switch and our light. And so once again, I'll be drawing in the hots and the neutrals to begin with, and we'll leave the grounds for the end. In reality, whenever I wire a box, I generally hook up all of my grounds first, get those out of the way, but I don't want to clutter up our page with all of our grounds. So our first cable has two wires. It has a hot wire and a neutral. Hot wire is our black, it's our ungrounded wire. Our neutral is our grounded wire, our white wire. And we spoke, earlier about our white wire is not to be broken. It is going to pass all the way through. We have two separate cables, and so our white wire is currently broken. So we're gonna patch it back together with a wire nut. And now our black wire is going to come up to our first three-way switch, and it is going to attach to the common screw. The common screw is the one that is by itself, that doesn't have one across from it. It is not the one that is on this side by itself. It is the one that does not have one across from it. There's not a screw across from it. It is oftentimes a screw that's been painted black, or it's a darker color than the two traveler screws. That's not always the case. It's not something to go by. So we're gonna just know that it's the one that's down by itself. When you're looking at that receptacle, or that switch in an upright position, there'll be you'll have two travelers on one side, and you'll have the common on the other. May not necessarily be on the bottom. If you've got that switch flipped over, then the two travelers will be on bottom, and that doesn't matter for the way that the switch works. We're going to hook the hot to that common screw that is by itself. Now our second our cable in between our switches, it's going to have a hot wire and a second hot wire, a red wire. These are what are known as our travelers. And those travelers are going to hook to our traveler screws. So we're going to come up and we're going to tie one end to one traveler screw. We're going to tie the other end to the other traveler screw. Right? The biggest mistake that I see on these is somebody hooking up this red wire down here by itself and hooking up the two blacks to these screws up here. And if it's not going to work properly, right? We have to maintain the path of electricity. So our electricity flowing in on our hot is going to go to the common, and then it's going to be fed out of one of these two travelers. Now, depending on which way the switch is going to depend on which traveler it flows out on. Now we go to the next box. Coming out of this cable, our first step, we take our neutral that should be unbroken, but it's been broken by being multiple cables. We're going to tie it back together with a wire nut, push it out of the way, because we're not going to be doing anything else with it. Just tying it together, push it back out of the way. Now I'm going to have my two travelers, my two hots, my black and my red, right? And so I'm going to tie those onto the switch across from one another. It's important to do these across from each other. We do not, if you put them on the same side, this will not work properly. If you put them diagonal from each other, this will not work properly. They go across from one another. So I always put the ones coming in on the bottom, the ones going out on the top. That's just to kind of to help me see the flow of the electricity. But you always want to make sure that the two travelers that are coming in from the previous switch are on either the top or the bottom, directly across from one another, and not on the same side of the switch, and not diagonal from each other. It will not work properly if you hook it up that way. I see that a ton in these labs. We want to make sure we have it hooked up correctly. Then we have another set of travelers going to our next switch, right? When we put a four-way switch in, we are breaking the travelers between two three-way switches. So we're going to have two travelers on the other side. So my red is going to come up, tie into one of the travelers. My black is going to come up and tie to the other travelers. Now I see this a lot where there's two blacks. There are two blacks on this side. There are two reds on this side, and that's the way I've done it in the drawing. And so somebody will just assume that if they put the two reds on one side and the two blacks on the other side, that they'll be fine. But if you swap the position of these, then if this black gets put on this screw, then these are at a diagonal and it will not work properly. We want to make sure that we have it hooked up just like this. And then going to our last three-way switch. Once again, we have our neutrals. First thing we'll deal with should be unbroken. So we're going to tie them together with a wire nut. Then we have our first hot coming in. Our first traveler is going to tie to one of the two traveler screws. Our other traveler, I try to call these travelers and not the hots because I want to remember the position of these. The travelers go on the traveler screw. And then my black wire that's feeding to my light, to the load, is going to go to the common screw. This one right here. And so then we come out of our last cable to our hot. And finally we tie our unbroken neutral to our light switch, tie those on with a set of wire nuts, and that is our finished diagram, other than we obviously have to have our grounds. Our grounds are going to come in, tie together at each one of these and pass through. Tie to our light, and then also with a stinger tie up to each of our switches. Okay, so that's our wiring diagram for lab number 6. There's also going to be a video on how to actually do the wiring on it. You're welcome to watch that once you finish this video. Make sure that you have these two drawings done for lab 5 and lab 6 before you come to class next week, because you will have to have those done before you're able to do the lab.